So to get a good accurate idea of the elevation for the images that we've gathered, I've overlaid an Ordnance Survey map onto some bees here. I've taken some care to try to line up the map with features on the Google Earth image. So particularly if you look at the Rottington Beck, there's a blue line on the Ordnance Survey map, and this stream here, as we fade out the Ordnance Survey map, you can see the line of those two streams, two small rivers in on Google Earth, and as we bring back in the dark blue line, or the blue line of the Ordnance Survey, you can see how well they correspond. So I think we've lined that up pretty nicely, and so we can use the contour lines now to establish our viewing height. So the contour lines are marked at 10-meter intervals. So this is a 10-meter contour line going around here, and the viewing point here, just near to the stream, is at some height lower than 10 meters. So we'll say about 5 meters, just to split the difference. The next observation height is between the 20 and the 30 meter line. So it's a 20 and the 30 meter line, and if you trace them around, we're right in the middle between those, so we'll call that 25 meters. And then we're 40 meters. 50 meters is a darker line, so every 50 meters there's a darker contour line to allow you to track your position a little bit more easily. So this one is 50, 60, 70 and 80, and we're between 70 and 80, so 75 meters. So we have a 75 meter observation, a 25 meter observation height, and a 5 meter observation height. So we can use those figures when we're analyzing the images we get. Now let's have a look at the images themselves. So this is a shot from the 75 meter viewing point, the highest point. You can see the low-lying land here starts to rise steeply as we head up to the top of the Black Combe hill or peak there, and I then pan the camera around. I change the zoom a little bit, that doesn't really matter for what we're looking at. That's the Sellafield nuclear waste processing plant, and I'll then head back and you can see the low-lying land at the sea again. So forgive the filming on this bit. This is from the lowest point, and I'm afraid the focus zooms, crashes and comes back in again. But we're filming the same little piece of land that pokes out, low-lying land, pokes out near to the Black Combe Peak. And if you just bear with the camera, it will come back into focus. I wanted to present all of this little clip so that you can see that we're not, I'm not trying to conceal anything at all. It's back out of focus again. The last part is probably the best. It's back into focus. Move it out to the end, and then work our way hopefully along to the left here, and you can see where the land rises up. So looking at the stills in a little bit more detail, this is a sort of zoomed in version of the 5 meter elevation photograph, and you can see that we can still make out clearly plenty of land above the horizon, and we can even make out pylons and things like that on this end. From 25 meter elevation, far more land is visible, and in fact the 5 meter elevation land is actually stopping here. We can't see any of this area below in the 5 meter elevation picture, and I will I'll confirm that in just a moment for you. We can make out some buildings down here, which is quite interesting, and you can make out tall structures, pylons or telegraph poles or something, or masts of other sort, maybe telephone masts and things like that poking up there. It's some 75 meters. Again, it's a little bit hazier because we're a little further away, and a higher elevation, we're looking through more atmosphere, but you can see plenty of land. This is the area where the 5 meter elevation is unable to detect any of this land, and from 75 meters we can detect another piece of land down here which is further down the coast. Now that may be due to the extra elevation, and it may be due to the lateral angle of observation, and I'll point that out in the next little section of this video, just so you can see. Obviously I'd need to return to the site and take some more images, trying to get the same line of sight, the same lateral angle for all the shots at different heights. These 3 shots are taken from very slightly different lateral angles, and that makes it a little confusing. I've put these together into a composite so you can see that they line up, and you can see that this area of land here from the 25 meter elevation, which is a characteristic profile, matches exactly what we're seeing here. And so you can conclude that the remainder of the land here is not actually visible in this shot here, presumably because it's below the horizon. The horizon line, if you were to take a horizon a line and draw it across here, just below where the land and sky meet, you would get a very similar pattern to what is seen from the 5 meter elevation. Not identical. The view, the angle view is slightly different, and obviously there are some mirroring atmospheric effects going on right near the horizon, probably in all the shots, but most noticeably in the lowest elevation, and you can see that at the end of the land here. But clearly we are seeing a far greater amount of land from higher elevations than we are from lower elevation at 5 meters, and some land at 5 meters is completely disappeared. I've also done some contrast enhanced shots of these just to make things a little clearer. Let's see if this will open up. Thank you. Okay, so here you can see more clearly the evidence of a mirroring line, so that the sky is being mirrored here, and so the mirror line would be roughly in the middle of that there, and so anything below that line is almost certainly a reflection. Whether the mirror line represents the true horizon or the hard water line that we see here represents the true horizon is something we can debate and discuss, but there is a mirror line there, but it's not sufficient to account for all the missing land in the other pictures. If we move on to the 20 meter elevation, you can see that our previous mirror line was somewhere up in this area here, and we have all of this land below clearly visible from a 25-meter elevation. And if we go up to the 75-meter elevation, the land in the distance becomes very clear to see, and we'll have a look at what that actually is in a moment. And again, we have a composite of these which allow you to line up the characteristic profile of the land so that you can see that indeed this land at the end is entirely missing, purely because of the elevation, not any other. No other explanation will explain why this land has disappeared from our view. Some of you might question why these houses here are not lining up perfectly one above the other. It's nothing to do with me stretching the image. I haven't stretched the images. I've kept the same, tried to keep the same proportions when doing this analysis. But what we do have is a different angle of observation. So I was further west when at 75 meters than I was at 25 meters, and I think slightly further west from the 25 meter one to the 5 meter one, and therefore the angle of observation is very slightly different for each one, which means that the match-up isn't absolutely perfect. And if I was going back to repeat this observation, I'd certainly want to make sure that I did my observations from the same line of sight but different elevations. Okay, so let's do a little analysis on Google Earth of what we ought to be able to see. I've drawn in here 3 lines from our observation points. Pink one is the 75-meter observation point, the red one is from the 25-meter observation point, and the green one is from the 5-meter observation point. Now, the first thing I want to check is whether we have a direct line of sight through to the land off Barrow-in-Furness. So the mainland that I've been looking at is this low-lying area here before the land rises up to the Black Combe peak here. But it turns out that if we draw in the line of sight lines as I've done, and we run them along the edge of the coast here, they're not quite perfect. The pink one could be a little bit further over, but you can see that I'm not looking over the land here at any point. We're looking, just running along the edge of the cliffs here. You can see that indeed, the pink one, remember, is the 75-meter line of sight, and you can see that in all cases we have a direct line of sight down to this land down here, and the land there is, if we look at the Google Earth elevation, which is fairly accurate for low-lying, for level and not too sharply elevated land, you can see that in this area here it rises to anything up to 22 meters above sea level, and this should be visible from all of our 3 vantage points, whether it be 5 meters or, so they're right along the 5-meter line of sight. We have 17, 18, 19 meters of elevation. I'm just going to shorten one of these lines to give us an accurate measurement of distance. So this is a 21-meter elevation point, which is pretty high. Okay, 21 meters it says on the bottom of the screen there, and the measurement, the distance to our observation point is 47.9. So we'll call it 48 kilometers. And we should be able to see this point from all three of our observation positions, if indeed the Earth is flat. And what we saw in the stills was that only in the case of this is not going to be any help to us. Let's see what we can find. I haven't got the appropriate thing open, so we'll go here. Yeah. Okay, so the 75-meter observation point, we could see clearly this land in the far distance. So this is the nearer land near to the Blackcomb Hill, which is away to the left here, and protruding out beyond that, and in both senses, both to the right and as we look at the direction we're viewing, further away we can see the land near Barrow and Furness. However, from 20-meter elevation, that land is not visible to us at all. Even though this is a more zoomed in picture and we'd expect to be able to see it more clearly, that land is not visible at all, even from 25 meters. And from 5 meters, we know that this land is just the very top of this land here, and even this land is obscured from our view. Now, the question arises, does that correspond to what we would expect on a curved Earth? So if we put in 48 kilometers and a viewer height of 75 meters, we should be unable to see anything below 14 meters. But anything above 14 meters, we should be able to see. And what happens if we go to 25 meters? From a 25-meter observation, everything below 55 meters should be hidden from our view, possibly even as much as below 71 meters should be hidden from our view. And indeed, that's what we observe. We don't see any of the land in the distance at all because it's only 20 meters above sea level, 22 meters maybe at the highest point. And obviously, if we go to 5 meters, then everything below 100 meters should be at that distance. Remember, this is 48 kilometers. At that distance should be obscured from our view. So the observation that we've made with regards to the land at Barrow and Furness is exactly in keeping with what we would expect from a curved spherical Earth. The curvature calculator is based upon the Earth being a sphere. Now, if I put in the line to the base of the Blackcomb Hill here, and we look at the distance involved here, we have 32 kilometers to this point. And although we can see land all the way back to here, which is 25 kilometers, let's stick with a distance of 32 kilometers to give the lower observation point, just to be consistent. We could also look from nearer as well. Let's do both, just to be thorough. So 32 kilometers, and the nearest point of land 24 kilometers. So 32, I'll do 32 and 25, I think. The other lines of sight come to, I've drawn them to the same point, and they basically cross here at the same place. So 32 and 25. So if we look at 32 kilometers, anything below 36, 37 meters should be hidden from our view. And we know, well, I'll show you in a second, that the highest land there is at 50 meters. So we would certainly be able to see some of it, but not all of it. 25 kilometers, we're looking at 18 meters being hidden, and again we'd expect to be able to see some land. Now at 25 kilometers, we're at that land is at sea level, so you've got to allow for it to rise up a bit. But I think 32 is the more interesting observation, the more accurate one. From 25 meters up, only a couple of meters would be obscured from our view at 25 kilometer distance, and at 32 kilometers, maybe as much as 10 meters or 15 meters would be hidden from our view. And at 75, if I could type, it would help. You're doing this in semi-darkness, which is a bit silly. Then none of the land at that distance will be hidden from view, or perhaps with no refraction at all, less than 0.1 of a meter. And at 25 kilometers, we actually have none of the land hidden from view. So if you can remember what we did there, and we look back at the pictures that we have. So this is the 25 meter point, so we will go to the 5 meter one first. The curve calculator says that we should see some land, anything above about 30 meters or 35 meters, something like that. And so what we want to do is know what these highest points are. Are they above 35 meters or not? And for the other two vantage points, there should be almost no land hidden at all. So we should see much the same level, just a tiny bit of land missing at 25 meters and none at all at 75 meters. And I think that the 75 meter and the 25 meter one, although these pictures here are slightly different zoom levels, if we look at our panorama ones where I tried to get the zoom levels about the same, we can see that these are, broadly speaking, the same kind of amount of height above the sea, above the horizon, whereas a large section is missing here. So what can we find out about the elevation here? Well, I do have an overlay of an Ordnance Survey map for this area, and again I've taken some trouble to line it up. You can see the railway line here. Comes in and out as a dark line on the Ordnance Survey and lines up nicely with the railway line track that you can actually make out on Google Earth. The coastline also lines up very well, and the main roads there lines up nicely as well, two main roads. So we've lined that up pretty well, so we can zoom in and have a little look at the contour lines. And the point to notice is that let's take that. No, I didn't save this. It doesn't matter too much. I'll go get that back. What we want to note is the high point. No, it's not from there. The highest point that we can actually see here, and where it is, and higher, increasing the opacity here, we get the contour lines in. Here is the top of Black Combe, and if we look here, almost in a direct line with Black Combe, we have a 50-meter contour line going around here. The darker line is a 50-meter contour line. You can see there's some quite steep cliffs in this area here as well. This land down here is a little bit lower. That's a 30-meter contour line there. And here we have a 50-meter. And so we know that some of the land at least is at 50 meters, and a large chunk of land here at 40 meters. And then so it goes down and then starts to climb back up again, and 40 meters plus here. And there'll be other areas along here. If you look at the Google Earth elevation, you can see that here we have on this contour line here, it's a 40-meter elevation. Google Earth has this at 48, 49, around about 50 meters, even 51 meters, slightly above 50 meters in the center of that. 40 meters and so on, then climbing back up on this side. So we know that there is some land above 50 meters and some land above 40 meters in this area that we're looking at. And the Earth, the curvature calculator for our 32, and this was about level with the Black Combe Hill. We use a 32-kilometer distance, and the curvature calculator says that everything below 36 or 37 meters with standard refraction should be hidden from view, and anything above that height should be visible. And what we observe from the 5-meter height is that we see this area here, which we know is 50 meters, a larger area here to 40 meters, and then we're presumably picking up other things that are at around about 40 meters in that area, leading up to the rise up to the Black Combe Hill. So in perfect agreement with the curvature calculators for the distance and the elevation height that we are observing from. So I think we can pretty much leave our our analysis at that point. We have, I think, shown clearly that we can see land all the way out to 48 kilometer distance. The land is still clearly visible, but only if we're the land of that elevation is only visible if we're at a high elevation, a 75-meter elevation. At a lower 25 or 5-meter elevation, land here becomes invisible, and at the 5-meter elevation, much of the land in this area becomes obscured from view as well. The question is, what is obscuring our ability to see this land here from 5 meters and the land off to the right-hand side from 25 meters? And the curvature calculator predicts that perfectly, and so the obvious conclusion is it is the curvature of the Earth that is causing the obstruction and not anything else. There's no other object between us and what we're observing, and the only alternative I have seen offered is that there is some bizarre refraction effect going on at the horizon, and all of this material, all of this land here is somehow obscured and in a narrow band that exists of light that exists at the horizon. Whilst that might be appealing to some people, it bears no has no science to support it. There's no demonstrable evidence that light can behave in that fashion and that things can be obscured in that fashion. So if you want to make a claim that it's the refraction at the horizon that causes the land to disappear, then please produce some science, some explanation that is logical, that makes sense, and then conduct some experiments to show that that effect actually occurs. Until you can do that, then since we have Earth curvature calculators that accurately predict this and also fit with all the other observations ever made about the shape of the Earth, then the obvious conclusion is that the Earth is indeed a sphere or spheroid of the size used for the calculators, which I believe is radius 6,371 or 3,674 kilometers. So I'm going to end that part here. I'm going to put up a little conclusions page at the end of this video. Thank you for watching, and stay tuned for the next installment from some bees.